This is a demonstration of Tom Sawyer software circular layout. We'll start with an example graph of about 430 nodes and 500 edges, and on the left we'll see a global layout result of that graph in circular layout. So you can see in this output that there are 20 clusters and that there are very few edges between each pair of clusters. Usually there is only one edge or two edges in between each pair of clusters. Generally, clustering algorithms try to minimize the number of edges between different clusters in the graph. It's a measure of how good the clustering is, and it's very difficult to do both performant clustering and high quality clustering at the same time. Next, we would like to determine what the structure of each cluster should be. So one of the methods we try to employ is to bring certain nodes within a cluster in order to reduce the area of that cluster. So I will zoom in on a particular cluster, and you can see in this example 5 nodes were brought inside the cluster. When you bring nodes inside the cluster, you're reducing the area of the overall cluster, and when you reduce the area of the cluster for a lot of clusters, it generally reduces the area of the entire drawing, which helps make a drawing more readable. So once you have that cluster structure, you can try to determine a global layout of a graph of clusters. So we'll determine node sizes based on the cluster structure, and we'll do a global layout of a cluster graph. Then we'll move each of the nodes in each cluster to the cluster graph node's position. So that's what helps us determine an overall global layout. Next, we would like to try something larger in order to demonstrate how performant the layout algorithms are. So let me select the subgraph. I'm going to select almost everything except for a few clusters on the right side. Now I'm going to duplicate several times, once, twice, 3 times, and now I'm going to demonstrate how fast the layout is. So if you see on the right over here the number in the drawing, we now have about 1,500 nodes and 1,725 edges. So I'll do a global layout now. 1, 2, 3. Yeah, so about a second is needed for the layout, and then you have animation and rendering. Next, I want to demonstrate circular layout, incremental layout. So I'm going to select the subgraph, and then I'm going to duplicate the nodes in the subgraph once, twice. So if I were to zoom in now, I would see several clusters, several sets of nodes that are on top of the original cluster. So I will zoom out now, and now I'm going to determine how to do incremental layout on this. So I'm going to call incremental layout, and just keep your eye on that cluster on the left there. So incremental layout is being called, and you can see that the layout is calculated with a larger cluster size now. And you can see the user's mental map is well preserved in the final result. Let me now call global layout on that result, and we can see the speed. Okay, that's it. Thank you very much.